The final tool in the toolbar is the Add tool. If we expand its options, we can see that it can be used to add a cube, cone, cylinder, UV sphere or an ecosphere. In fact, it's offering an alternative way of adding most of the 3D shapes we would normally insert into our scene by using the Add Mesh option in the 3D viewport's main menu. Only the torus and monkey are missing. However, this tool offers a much more dynamic way of adding those items than is possible from the Add Mesh menu. Starting with the default Add Cube. When we move the mouse pointer into the 3D viewport, it displays a surrounding grid pattern. This represents the base plane on which our new object will sit. Once we've selected a position, pressing down on the left mouse button marks one corner of the cube we are about to create. Dragging the pointer adjusts the size of the base, which shows in a wireframe style. And when we finally release the mouse button, this marks the diagonally opposite corner from our starting position, finalizing the area of the cube's base. The next step is to move the mouse vertically, that can be up or down, to define the third dimension of our cube. A last click of the left mouse button fixes the final size of the box, and it now appears in solid rather than wireframe form. Of course, what we've created is no longer a true cube since all its sides are no longer of equal length. But just for simplicity, we'll continue to call it a cube. We have the usual last op panel available to us with the same options that we get when we've created a cube using the Add Mesh option. In the sidebar, we can adjust the dimensions of our new box. If we've adjusted the size, we need to remember to select Object, Apply, and Scale to reset all the scaling factors to 1.0. We mentioned in the primitives video that failing to do this can cause a lot of grief later in the modeling process. We'll see examples of those problems in later videos. Notice, however, that if the box size was set solely while dragging out its dimensions before it switched from wireframe to solid mode, that the scale factors do not change from their initial 1.00 value. As we move the mouse around the 3D viewport, we can see that the grid realigns itself to lie flat on any face that it moves over. And if we drag out a new cube over one of these faces, our new mesh sits perfectly flat on the existing face. If we place the latest cube on a side face, we can see that the cube has been rotated to the new alignment, which is confirmed when we display the local axes. There are several parameters associated with Add Cube. These can be seen at the top left of the 3D viewport. But before we look at these in more detail, be aware that you're unlikely to need to make adjustments to these parameters. Depth has control over which plane in 3D space the base of the box will appear on. There are 3 options in the drop-down menu. To help understand each option, we'll start by moving the 3D cursor to some random position and then construct 3 plane meshes. Each plane will be in line with imaginary axes whose origin is at the position of the 3D cursor. The first plane lies along the X and Y axes lines. We'll call this the XY plane. Next we have the XZ plane and finally the YZ plane. Now we'll hide those planes, so they have no influence on where the Add Cube tool adds a new mesh. Surface is the default setting for the depth parameter. This places the base of the new cube on any face that is under the mouse pointer. If the cube is constructed in an empty space, its base is aligned parallel to the XY plane. In fact, the new cube's base actually sits on this plane, which we can see if we make the 3D cursor's XY plane visible. Cursor plane is the next option for the depth parameter. If we create our new cube in an empty area, we can see that it again sits on the 3D cursor's XY plane. If we now try building a new cube on the sides of the default cube, the mesh under the mouse pointer adjusts its orientation and it may look like we have succeeded. However, this is just an optical illusion which we can see if we move to a new viewpoint. But if we make the XZ and YZ planes visible, we can see that our latest cubes lie on one or other of these planes. Cursor view is the final depth option. To help understand how cubes created using this option are oriented, we'll add a new plane aligned with our current viewpoint, expand it, name it viewplane, and then hide it. Now let's add some new cubes. Again, it is easy to be fooled that the new cubes are being attached to the default cube. But if we change viewpoint, we can see that they are not. This time, at least on vertex of the new meshes will lie on the viewplane. We'll return the depth setting to surface before we move on. The next parameter is orientation. Surface orientates the z-axis of the new cube to align with the normal of any existing face that the mouse pointer is over. When over an empty space, the alignment of a new cube's z-axis depends on the transformation orientation setting. When this is set to global, the new cube's z-axis is aligned with the world z-axis. Remember, all global axes align with the world axes. When transformation orientation is set to local, the new cube's z-axis is aligned with the local z-axis of the last selected object. Default uses the current transformation orientation setting to determine the new cube's orientation. So, if transformation orientation is set to global, the new cube's z-axis aligns with the world z-axis. If transformation orientation is set to local, the new cube's z-axis is aligned with the z-axis of the last selected object. This means that the new cube's orientation is unaffected by any surface we might place it on. We'll return orientation to surface before continuing. The third parameter is snap to. Its initial value is geometry. This allows us to snap to any part, vertex, edge, edge middle, or face, of an existing object. We need to hold down the Control key to switch on snapping, then we can snap the starting point of our cube to the required element. When snapping to a vertex or edge, just a small movement of the mouse pointer will switch the orientation of the new cube's base from one face to another that is connected to the same element. The second snapping value is default. If we use this setting, holding down the Control key will allow snapping only to the element or elements selected in the main snapping menu. The ellipsis, that's the 3 periods, hides another set of parameters. Plane axis determines which is the final dimension to be defined when we build a new cube. By default, it's the z-axis, so our base lies on the xy plane. If we select the Auto Axis checkbox, the cube's final dimension is determined by the viewpoint. We'll reset these parameters before we continue. Base origin determines what part of the cube's base the mouse pointer marks when we first click the left mouse button. When set to edge, the position marks one corner of the base. When set to center, the position marks the center of the base. Base aspect free allows the base to be a rectangle of any size. Fixed restricts the base to be square. Height origin determines how the height grows when we add the third dimension to our cube. Free means that the cube grows in one direction away from the base. Fixed causes the cube to grow equally on both sides of the originally defined base. Height aspect free allows the cube to be of any height. Fixed cause the height to be the same length as the longest side of the cube's base. To speed up origin and aspect selections, we can hold down the Alt key to switch to the currently unselected origin setting. This applies to the base or height origins depending on which part of the cube build we are currently at. Holding down the Shift key performs the same type of function as the Alt key, but this time it's for the aspect setting. At last we've covered the basic parameters that apply to all the meshes that can be created with the Add tool. However, each of the other Add Mesh options have one or two additional parameters. Next up is Add Cone. After it has been created, we have the last op panel where we can change the various options including vertices on the base, radius 1, which is the radius of the base, radius 2, which is the radius at the top of the cone, depth, this is the height, and the base fill type. When we create a cone using the Add Mesh Cone option, many of the settings in the last op panel carry over to the next cone to be created. But this is not true when we use the Add Cone option. Those values revert to their default settings when a new cone is created. However, there are two new parameters that appear alongside the other Add tool parameters, and these allow us to specify the number of vertices and the fill type for all future cones created using Add Cone. Remember, because we have a free hand when creating the base shape, we won't have a round base unless we hold down the Shift key. Add Cylinder has the same two additional parameters as Add Cone. And the same need to hold down Shift to create a circular base. Add UV Sphere allows us to set the number of segments and rings. This time we need to hold down Shift while defining both the base and height if we want a perfect sphere. Add Ecosphere has a subdivisions parameter. Remember not to set it higher than about 5 unless you have a very powerful machine and lots of memory. Again, holding down Shift will be necessary if you want it to be round.